So in the last video, we talked about how to compute the average rate of change and what it was. How do we sort of visualize what this is? Well, the average rate of change, remember the formula for this is, we're looking at delta y over delta x, and for a function y equals f of x, the way this turns out is as f of x2 minus f of x1 over x2 minus x1. Come on now. Yep, x2 minus x1. Okay. So, this quantity, the way this is constructed, should probably remind you of a slope of some sort, right? A slope of a line that passes between the points x1, f of x1, and x2, f of x2. Right? It's the slope of the line that passes through these 2 points. Slope of that. Okay? Or maybe I should add in here line through. Okay? So what does this look like if we draw it on the same graph as the function f of x? Oh god. Okay, so what does that look like? Oh, let's say here's some axes. Let's say here's f of x. If we say here is x1, then this height is f of x1. Okay. If we say up here is x2, then over here is f of x2. Right? This point here is our x1 f of x1. This point up here is our x2 f of x2. Right? And then the line that the average rate of change is the slope of would be this one here. Right? This has slope given by delta y over delta x. What is this delta y and delta x? What are these quantities? Well, this distance right here, this distance is delta y. This distance is delta x. Right? So you can even relate it back to, the old rise over run thing. Here, this is how much the function rises between these 2 values. And this distance here, delta x, is how much the function runs between these 2 values. Right? So that's just a quick little geometric interpretation of what the rate of change is, or the average rate of change.